Hi, this is Mrs. Clark, and this is my video on how to interpret data from a box plot. So we learned how to make a box plot, but now we're going to be looking at how do we read information from a box plot in order to make some generalizations or interpret what exactly is being shown in the box plot. So if you look at the top of this paper, we have kind of a division out on how the box plot shows information, how it separates the data. So it separates the data into 4 equal groups, with 25% of your data being between your minimum and your Q1, 25% of your data being between your Q1 and your median, 25% of the data being between the median and the Q3, and the last 25% of the data between the Q3 and the max. So if we're looking at that as a box plot, this piece from here, Q1 to Q3, is actually our box. So this box is representing 25% and 25%, so 50% of our data. So our box represents the middle 50% of our data. The left side of the box is 25%, the right side of the box is 25%, but the box itself represents a total of 50%. Half of our data is in that box. So as we're looking at and comparing these two box plots down here, we can compare and see where is the data lying. How is it spreading? Is it spreading equally in both of the box plots? There isn't a lot that we can see from a box plot other than our 5-number summary. But if we look and compare them, we can use some of that information to say some things about Test 1 and Test 2. So what can we say about the scores of Test 1 and Test 2 based on the box plots below? Now hopefully you're noticing that some of the 5-number summary in both of these box plots is the same. They have the same minimum, they have the same maximum, they have the same median. Even the Q3 is the same. What's different is the Q1 on each box is different. So if I was thinking about what these test scores look like, I don't actually know any of the test scores except for I know that the lowest test score was 3 and the highest test score was a 21 in both tests, but that's all I know. None of the other things here actually tell us any test scores. They just tell us how the test scores are spread out. So if we're looking at the way the box is representing the data, this little whisker on this side represents 25% of the data. Same thing with this little whisker on the bottom. And then this right half of the box is 25% of our data, which seems to be equally spread for both tests. But when I look at this left part of the box, it seems to be that the scores are closer together here than they are in this box, where the scores are a lot more spread apart. Still, it's 25% of the students' scores are here, but these are more spread apart because the box is bigger. And then this whisker is really long, so there's a lot bigger spread in the lower 25% of this one, and this one's a little shorter, so these are tighter together. And so if I think about those 25% as I go through the statements at the bottom, I should be able to determine what can we conclude looking at this box, these two box plots. So first it says, what percent of the scores in Test 1 and Test 2 are below 16? So if I look at where 16 is right here. So if I'm saying below, that means I want less than, so I'm looking this way. So that means if I look at either the top or the bottom, since they both line up exactly the same here, it's 25, 25, and another 25, to say that 75% of the test scores were below 16. The same thing is true for Test 1, because it's 25 and 25 and 25. So we can say for either test, 75% of the scores are below 16. If I want to look at the next one, it says what percent of the scores in Test 1 are above 6? Well, here's 6 for Test 1, and we want above 6, so going this way, we've got 25%, 25%, and another 25%. So now we have a low-end score of 6, and 75% of the scores are above that. So we can look at 75 in two ways. 75% is below one number, but it's also 75% is above a different number. The third statement here says, what percent of the scores in Test 1 are between 6 and 16, whereas in test 2 they are between 9 and 16. So if we look specifically at the two box plots, and we try to look for where those two ranges are, here between 6 and 16 is this. Actually, I need a different color. Hang on. Between 6 and 16 is this piece, which is the whole box, and then between 9 and 16 is this piece, which is also the whole box. So for either test 1 or test 2, it's the entire box, and we know the entire box is made up of 50% of the data. So 50% of the scores in test 1 are between 6 and 16, and in test 2 it's between 9 and 16, that 50% of the scores. The last one here says the top blank percent of the scores for both tests are above 16. So here was our division for 16 before, but now we're looking above. So on this side of 16 is just the whiskers on both tests. So the top 25% of the scores for both tests are above 16. So here's how we can use the breakdown of the individual percentages and how the box spreads out the data to make some generalizations, and kind of like we were doing with the bars and the histograms, kind of combine them together. We can combine some of the percents together to make a larger group and give a generalization about that, or to say some are above, this percent is above or below this specific score. Alright, so make sure you get that glued into your notebook, and let me know if you have any questions. Thanks for watching.